Hi, today I'm going to discuss what is normalization in database management system and why it is needed. Normalization is mainly done in database management systems to reduce redundancy, improve data integrity, and reduce anomalies like insertion, deletion, and updation anomalies. For example, we have some data. For example, there's some student. Uh, for example, student one with SID 0, S name, this is student name as let's say Akshat, and department CSC. Also, he has like two courses, for example, DBMS and OS, which each of them have subject code and a instructor office and instructor code. And suppose we have a second student with SID 1, that is Rahul, with department CSC or CSC, and courses like only DBMS. So here the data is in 0NF form because there's redundancy present. For example, we have like repeatedly defined courses. In this, that DBMS is repeating in both the students, so we don't need to repeatedly define them again and again. So to make this table to 1NF for, what we need to do is we need to reduce that. So here the student Akshat has taken two courses, DBMS and OS. So we can convert it to 1NF by making two separate rows instead of one which has two subjects mentioned. So now the new rows in the table become SID 0 Akshat CSC, course 1 DBMS, and second is Akshat, with same ID, same name, same department, but a different course. And third is Rahul with uh, DBMS is address code, but it still doesn't have solved the problem of redundancy. And we have insertion, deletion, and updation of anomalies. For example, if we update the instructor's office, we need to update it in all the rows, which is not at all very good for our database. Also, there could be insertion anomalies like we can't insert a new course unless a student has enrolled in it because it's present in the same table. And if the student ID is none, then the course can't simply exist. Also, we can't delete a course for deletion anomalies, because if we delete a course, we might lose the info on the courses. So what we need to do is now convert this into 2NF form. We need to check the function dependency of the variables and model it the data according to that only. So in our table, SID has a direct functional dependency to the student name and the department, because SID is like a particular student. So particular student always belongs to a specific department as a has a fixed name. So we could make that and make a table out of these three. For example, SID, name, and department. Second table we could make is enrollment, that is in which courses a particular SID is enrolled. So we could model a second table enrollment with columns SID and course ID. The third table we could make is for the courses with the attributes like course ID, course name, instructor office, and um, instructor ID. So now we still we have solved the previous problem, but we still have some anomalies. For example, if we still have the transitive dependency, because the instructor office doesn't directly depend on the course ID. Instead, it depends on the instructor ID. So we need to also change that, because we don't want key. it should have a transitive dependency. So transitive dependency is basically course ID affects the instructor ID, and instructor ID influences the instructor office. But we want key instructor office should also be straight away manipulated by the instructor, the course ID only, which is the primary key of the table courses. So to correct the mistake, what we do is we make a separate table for instructor also, which has instructor ID and instructor office, and the previous columns like courses and enrollment, the course, not courses, enrollment and student stays intact. Now BCNF. So now we have solved most of the problem, but there are some remaining problem. Most of the times in real world we don't need to take care of BCNF, but for the completion sake, I am going to discuss it also. So basically, BCNF is for every functional dependency, that is x to y. X must be the super key only. So, for example, let's say a relation exists: student, course, and instructor. A course can have multiple students, and an instructor also can teach multiple courses. But each course has exactly one instructor. So, the candidate keys here exist are student, comma course, and student, comma instructor, with a function dependency of course on the instructor. So, as instructor is not a super key here, because the instructor alone don't determine the student. So the table is not in BCNF, and we need to further divide it into two tables to make it BCNF normalized. So yeah, that's it. Thank you.